Hello, and welcome to our webcast on General Principles of Proficiency Testing for Analysts. The topic of this webinar is based around the expertise of Fera science in the proper implementation of a wide range of proficiency testing services. The global market for food testing services is projected to undergo enormous growth in the next few years, accompanied by increasing regulation of food standards. In addition, consumer awareness of food safety, authenticity, and the effects on health is also driving this demand. These demands must be met by accurate, robust, and reproducible testing methods. In this webinar, we will cover several topics, including the testing processes themselves and the importance of using blanks and reference materials, considerations of sample stability, particularly if samples have been in transit or in storage for some time, results of testing, the appropriate analysis and interpretation of those results, and good practice for recording test methods and data, and quality control and reproducibility. To discuss these topics, it's my pleasure to introduce Mark Sykes. Mark has been a senior scientist at Fera for over 20 years and is the scientific advisor for proficiency testing, responsible for overseeing the scientific integrity of all proficiency testing services. Mark's background and expertise is in analytical chemistry, in particular mass spectrometry, and his expertise includes techniques that are essential for robust food testing procedures. Mark has an extensive record of peer-reviewed science and is active in the scientific community, publishing his work on proficiency testing data and speaking at international conferences and workshops. He is also the Fapas representative for the UK Proficiency Testing Working Group. So I'd like to hand over to Mark and hope you find his discussion interesting and informative.
Thank you very much for that introduction. This presentation came about because a lot of our customers want some help in interpreting the outcome of a proficiency test and want some understanding in the principles of proficiency testing, how it works and what it means for them. So this presentation is aimed at that audience. Okay, so relevant questions to ask that we're going to address is: how does proficiency testing work? What happens when it goes right? Equally important, what happens when it goes wrong? And overall, what can we learn from this? This presentation is split up into bite-sized sections so that you can dip in and out as you wish or go directly to the topic of interest. And the topics are listed here on this slide and they will be in this order. So we start with section 1, which is the general PT process. What is proficiency testing? How do we describe this to someone who is not familiar with it? If I ask you to do a routine analysis, so I'm a customer of your laboratory, how do I know that you're giving me the correct answer? Ultimately, this is what it's about. So, as a laboratory, we might have a validated method. We might have some kind of internal quality control mechanism. We might have accreditation, typically to an international standard, ISO 17025. And these are all good and proper things to have. But what they have in common is that they are largely internal control mechanisms. That is to say, the control is within the scope of the laboratory and there is no external influence. And that is where proficiency testing comes in. It can help give you a measure of the bias against an external reference that is one that the laboratory has no control over. The overall process starts with test material preparation, which might include natural levels or spiked samples. The PT provider then has to carry out a homogeneity test. So this is to establish that all the samples that each participant receives is all the same. And typically we would do this by taking 10 samples at random and analysing them in duplicate. And we would use a laboratory to do this for us, which typically would use an ISO 17025 accredited method. Then it's the turn of the participants to receive their sample, carry out their analysis and report the result. Once we have all the results in, we do a data assessment. That is quite involved. It involves statistical assessment, but the outcome is the Z-score, which participants are familiar with. And this is all produced in a report. At any one point in this process, we can learn from the experience and improve the PT for next time. This process is also described in the International Harmonised Protocol for the Proficiency Testing of Analytical Chemistry Laboratories and is also described in ISO 17043, which is the standard general principles for proficiency testing providers. So, the test material itself, this is important to get right, and it could be liquid or it could be solid. If it's a liquid, is it an oily liquid or is it aqueous? What about stability? The matrix itself could be unstable or the analytes could be unstable. What about compounds that bind to the matrix? Are there physical chemical parameters related to that material? How are we going to store it or transport it? What kind of containers should we use? Metals, for example, we need to avoid glass containers because they would contaminate the sample. Are we looking at incurred or natural analytes, or do we have to spike in the analytes artificially? What about test materials that are unintentionally contaminated, for example, with genetically modified organisms or allergens? These are questions that the PT provider needs to address. But importantly, as a participant in a PT, how do I know that my test material sample is the same as your test material sample or anyone else's taking part in this PT? As part of the PT process, I mentioned the homogeneity testing. So what does this look like in practice? These are typical homogeneity plots that may or may not occur. So plot number 1 is really what we're aiming for. These are the 10 samples analysed in duplicate, so you can see a blue cross and a red cross associated with each sample. This gives us a measure of both the analytical variance in that homogeneity test as well as the sample to sample variance. Plot number 2 shows that the sample to sample variance is not too bad, but sample number 2, the duplicates, are far apart. the Red Cross and the Blue Cross are very different. This indicates a possible analytical error during the homogeneity analysis, and we can account for this in the statistics. Plot number 3 shows sample number 9, where both the analyses, the Blue Cross and the Red Cross, are very different to the other samples. This indicates a lack of homogeneity for that one sample. Plot number 4 is a more extreme version of plot number 3, where it's showing clearly that the sample is not homogeneous. There is a statistical process underlying this analysis, which is too far-reaching to go into detail in this presentation, but these plots are the outcome and the type of thing we're looking for as a PT provider. And then finally, in the process, it's the analysis of the sample by the participant. So we help the participants as much as we can. We provide a deadline and online reporting for the results. But please follow the instructions on the letter that accompanies the test material or that is available online associated with that sample. The instructions are there to help you, but sometimes there might be critical parameters in those instructions to be followed. Usually you will use your own routine method. There should be nothing special or challenging about a PT. It should be normal. Sometimes we might ask for critical method parameters and information regarding those parameters to be returned with your results. Further method details. This is an optional part of the proficiency test, but we do encourage participants to submit method details so that we can capture these and look for trend or analyse for trends with methods against results. This is very useful information both for us as a PT provider and for other participants in the proficiency test. But overall, the PT should be fit for purpose.